Alright, so we're back with our diverging lens. We've found our image right here. Now what we want to do is mathematically characterize that image. What we want to do is we want to find out what is the image distance, and we're going to find that out using our usual equation. Okay, so here is a label of our image distance, or our DI. From here, we're going to use our usual equation as I stated, but we have to remember one tricky thing about these diverging lenses is that your focal length in a diverging lens actually is a negative number. Okay, so when we write our equation, 1 over dO plus 1 over di equals 1 over f, and we solve that thing for our 1 over di, that's 1 over f minus 1 over dO. We have to include that negative sign with our focal length. So 1 over negative 10 minus 1 over 15. Okay, so that makes this term negative, and this term is negative. So we actually end up with about negative 2.5 over 15, just kind of doing common denominators a different way there. So what that means then is our di is going to be negative 15 over 2.5, which gives us roughly right around, I think, about 6, negative 6 that is. Okay, negative 6 centimeters. And let's check and make sure that that matches up with our diagram. Here's our object, or our image. Our focal length is 10 centimeters, negative 10 centimeters, but 10 centimeters from the lens, and it looks like our image turned out to be just a little bit more than halfway from the lens to that focal point. So 6 is reasonable. Alright, so that's 6. Also, we want to be able to find out our magnification. Our magnification of this thing, the usual, is negative di over do. Okay, and so we have a negative 6 over 15. And that, of course, turns out to be a positive number. That's positive 0.4. That's our magnification. It's positive, meaning that it is upright. That's correct. It's less than 1, meaning that it's been reduced, and that's also correct. Okay, so some things to look out for with diverging lenses are these negative signs. Okay, that negative in front of that 6 here just means that that image has been formed on the same side as the object. Okay, our negative focal length, or our negative focal length, comes about because this thing is a diverging lens. And of course, we can also classify our image as real or virtual. And you ask yourself, did the rays of light actually converge there? The answer is no. So we have to call this thing a virtual image.